Good day, sir. So today we will discuss about our project titled Applied Cryptography Application. So this application is using Streamland. So the course name is CSAC 329 Applied Cryptography Application. My co-members are Don Robert de Lima, Belgado, and yours truly, Marevel Regaspi. So this application is protecting personal information from unauthorized access has become as important in a world grows more digitally connected. So the cryptographic application is the achieving these goals by ensuring the confidentiality, integrity, and authenticity of digital data from securing stored information to protecting online communication. Cryptographic techniques are essential for maintaining trust and security in today's generations, and also secure communication by using algorithms. So there are um, choose a cryptographic algorithm. So the user will choose um, in which need they want to use. So first, symmetric algorithms. There are Caesar cipher, Burnham cipher, and Virginia cipher. And in the asymmetric algorithm, or SA, and Delphi-Hellman. And lastly, in hashing algorithm, SHA-1, SHA-256, SHA-3, and MD5. So these algorithms um, transform readable data into unreadable format, which can only be reverted by authorized parties. In it underpins a wide range of everyday application, including secure message, email encryption, digital signature, and online banking. This project is provide a hands-on interactive platform for learning and experimenting with commonly used cryptographic algorithms. This purpose is to build a user-friendly application developed using Streamlit that allows user to perform encrypt and decrypt and hashing on real-world data. By integrating multiple cryptographic tools into single accessible interface, the project seeks to enhance user understanding of core concepts such as asymmetric algorithms, and hashing and secure key exchange. This practical approach not only support academic learning but also prepare user for real-life application in the field of information security. So there are three objectives. First is to implement these cryptographic algorithms, including the symmetric algorithms, asymmetric algorithms, and hashing techniques for securing text and files. And also develop the initiative user interface using Streamlit to allow user access to encryption, decryption, and hashing function. And lastly, the last objective is ensure secure data processing for confidentiality, integrity, verification, and password protection. And for the back end and front end, we use the front end, this Streamlit, and also in the back end, the Python.
Good morning. I am Donn Robert Lima and I am here to discuss all of the implemented algorithms on our web app application. So let's first things first. We have three sets of algorithms. We have symmetric, asymmetric, and hashing algorithms. The first we need to discuss are symmetric algorithms. So we have Caesar cipher. This is one of the oldest known ciphers used by Julius Caesar. This kit is just a substitution cipher. So the way it works is just it ships letters by a fixed number of positions in the alphabet. So to decrypt it, we just reverse the shift. Let's proceed to Burnham. So Burnham is another symmetric cipher invented by Gilbert Burnham in 1917. It is considered unbreakable when it used as a one-time card. The way it works is just the plain text is XORed with a random key of the same length. So, let's set the code. We just sort it here. Libraries, none. We just use the ordinal and then character functions in Python. Let's proceed to Engineer, another symmetric cipher developed by the 16th century by Juan Bautista Velasco, but later misattributed to Blaise de Vigenère, hence the name Vigenère cipher. So the way it works is as it used a repeating keyword to apply multiple Caesar shapes to the plain text. Then let's proceed to asymmetric algorithms. We have RSA. So this is an asymmetric algorithm introduced in 1977 by Regaspi, Shamir, and Adrian. That's RSA. It's widely used for data transmission. The way it works is that public-private key pair generates, and then it encrypts it using mathematical operations. The next is Diffie-Hellman key exchange. So the first public key exchange method in 1976 developed by Whitfield Diffie and Martin Hellman. It does a secure key exchange over a public channel. So both parties agree on prime number and generator key. Each party generates a private key and corresponding key. They exchange public keys, and then each party computes the shared secret. We have AES integration. So the shared secret is then converted into a symmetric key. This key is then used in advanced encryption standard for encrypting and decrypting the actual message. So the libraries used is random and then fun. Hashing algorithms are one-way cryptographic functions. We have SHA-1, designed by NSA in 1995, consider weak as collision vulnerabilities. It produces a 160-bit hash from any input bitwise. SHA-56, part of the SHA-2 family, published by NIST in 2001, common in blockchain and secure. SHA-3 released by also NIST in 2015, na it now uses the ketchup algorithm, distinct from SHA-2's design. Then MD5, developed by Ron Rivers now Kyoto conditions. This is the summary table of all of the ciphers implemented, the algorithm, what type it is, and the libraries used, and the file responsible in the program.
Hi, good day everyone. My name is Belgado, and for today's video, I will walk you through the platform titled Cryptography web application. So for today, I will show you the sample run for this website. So let's start. Let's see. So at first, we should be access the app link, sidebar navigation, that you can choose the different cryptographic algorithms such as the symmetric, asymmetric, and hashing algorithm. So in symmetric algorithm, we have the Caesar cipher, Burnham cipher, and Vigenère cipher. And for asymmetric algorithm, we have the RSA Diffie-Hellman. And for the hashing algorithm, we have the SHA-1, SHA-256, SHA-3, and MD5. So let's start. Let's start in the Caesar cipher. So entire plain text, Bitsoy, And encrypt natin siya. So, ayan. And after that, kung gusto nyo i-encrypt siya, i-decrypt siya, i-copy nyo lang siya and ilagay siya as ciphertext. And palitan nyo to. And ilagay nyo here. So, i-decrypt na natin siya. So, ayan. Same na yung lumabas. Samantalang ipag-browse na, i-try naman natin kapag mag-browse tayo into the file. So, ayan. Browse files muna tayo. Kapag i-download. So, encrypt na muna natin siya. Tingnan natin kung ano yung nakalagay dun sa joy.txt. So, i-copy. For the decryption, i-paste. Tanggalin nyo na muna to. I-off nyo na muna to. Kasi for decrypt na siya. And, tanggalin nyo yung joy.txt. So, ayan. Nakita natin kung ano yung laman ng joy.txt. So, that is for Star Cipher. Dumako naman tayo sa Renam Cipher. First, mag-enter tayo ng plain text. And, i-encrypt natin siya. So, ayan. So, ikakopy natin tong dalawa, yung encrypted text at yung key used. So, para ma-decrypt natin siya, ikakopy, ilalagay muna natin siya sa notepad. And, click the decrypt. So, ikakopy natin to na encrypt text natin kanina. Tapos, yung key. Ayan. Ayan na yung na-decrypt natin. So, na-decrypt natin yung plain text kanina. So, what about if you wanna drag or drop a file for encryptions and decryptions using Renam Cipher? So, idadrag natin to as sample. I-encrypt natin. So, ayan. Again, copy the encrypted text. Ilalagay muna natin siya somewhere o kaya ilagay natin siya sa notepad. So, para hindi tayo mahilo, ilagay natin dito. And the key used. Ika-copy. And i-paste sa notepad. Tapos, tatanggalin na natin to. And choose decryption. Ika-copy yung encrypted text into plain text. Tapos, yung key na ginamit kanina. Ayan. So, ayan. Na-decrypt na natin yung files kanina na pinag-download natin or trinag natin or pinag-upload natin. That's it. So, dumako naman tayo sa Visionary Cipher. So, let's type joy. And, pwede din na same cipher key yung gamitan natin. So, encrypt na natin siya. So, yan yung encrypt niya. So, i-copy to. And, for the decryption naman, tanggalin. And, decrypt. So, na-decrypt na natin siya. So, yung joy kanina, ay na-decrypt natin. Na-encrypt at na-decrypt na natin. So, what about if we gonna use, upload the file? So, tanggalin naman natin itong mga ilagay natin. So, browse files. Downloads. So, mag-upload tayo ng files. So, again, mag-isip tayo ng kahit anong cipher key. Say, for example, here. So, encrypt na muna natin siya. So, yun na-encrypt na yung text. So, i-copy natin, tapos tanggalin natin tong file na to, and mag-decrypt na tayo. I-tanggalin natin. Yan. And eto na yung decrypted text natin. So, ayun yung decrypt text natin. Dumako naman tayo sa symmetric algorithm. So, click the symmetric algorithm. Simulan natin sa RSA. Enter plain text. Do start. And, mag-generate na muna tayo ng new k-pair for, if gusto natin, new k-pair. Tapos, for encryption, kapag gusto natin mag-encrypt, ilalagay natin siya. I-copy natin yung public key sa taas. And, na-encrypt na siya, guys. Ito na yung na-encryptan niya. And for decrypt naman, i-copy to. And yun yung ilalagay natin sa plain text. Tapos, since magde-decrypt na tayo, gagamit na tayo ng private key. So, tatanggalin natin itong nilagay natin kasi public key siya. And for encryption siya. So, private key na muna tayo. So, magde-decrypt na tayo. So, ayan. Ang na-decrypt niya, kung ano yung nauna, ito naman yung kung ano yung nauna, parehas yung kinalabasan for decrypted the message. So, ayan guys. Dumako tayo sa Diffie-Hellman. Plain text. Hopefully this one. Parser for service choice. And generate KL. Mag-generate na muna tayo. Again, you can also drop or drag your text files kung gusto niya. Pero for now, ang ginawa na muna tayo nating example is through keyword through text base. So, encrypt muna tayo. So, yan. Ang encrypted text natin is ito. Encrypt text. So, ilalagay natin here yung na-encrypt text natin. Ito. And, i-decrypt natin. So, ayan. Nung na-decrypt na natin, parehas nung plain text dito. So, that's it for the asymmetrical algorithm. And that's all. So, quick recap muna nga tayo of what we have achieved today. So, first, we demonstrate text-based encryption and decryption using different cryptographic algorithms. Also, we showcased file-based processing. We've also applied real-time hashing using different hashing algorithms such as the SHA-256 and MD5. So that's all. Thank you for watching for this walkthrough of for this website. So if you like to explore the code, you can check our repository in the description box. Also, we welcome your feedback, your suggestions. So feel free to comment your suggestions, comments. That's all, and happy encoding! So for hashing algorithms naman, we have SHA-1, SHA-256, SHA-3, and MD5. So let's start first for SHA-1. Enter text, Marevel. Okay. Awaiting input or file upload. Hintayin na lang natin siya. Let's wait for that. So, ito na yung na-hash niya. So, what about we should upload file? So, again, kung ano yung ginamit nating sample kanina, yun din ang gagamitin natin for the entire process. So, for the download, so, tada, ito na yung na-hash niya. So, pwede nyo siyang i-copy and paste. I-copy and i-paste sa documents. So, what about for SHA-256 naman? For SHA-256 naman, enter text, Donn, where, okay, we're awaiting text input or file upload. So, naglo-loading po siya. Ito na yung na-hash niya, guys. So, again, upload files. If gusto niyo na, gusto nyong ma-hash yung text files niyo. So, ito na yung na-hash gamit ang SHA-256. For SHA-3 naman, click to SHA-3 and ligaya. Enter, click, and awaiting text input for our file upload. So, hintayin na lang natin siya again. Habang binabasa na. So, tada! Ito na yung na-hash niya gamit ang SHA-3. So, if you want again to upload the files, browse files again and drag, upload that, and tada! I think mas madali kapag ginawa nyo muna siya ng text files and upload. So, ayan. Suggestions lang naman yan, guys. So, what about for MD5? CS3A. Ano kaya ang mga hash niya? Again, lahat ng process, lahat ng cryptographic algorithm is merong ganito sa unahan. May navigation for you to able to read, understand, and might as well magka-interest kayo when it comes to cryptographic algorithm. So again, for CS3A, ang nahash nyo ay eto. Pwede nyo again siyang i-upload, i-download, i-copy, and i-download. I-copy and i-paste sa inyong documents. So for the browse files, again, gagamitin natin yung ginamit natin the entire process. So, eto na yung nahash nyo, guys. That's all. Thank you. That's all. Thank you for the cryptographic algorithm for hashing algorithm.